Okay, so I'm building a power distro for a small home shop, and I'd like to have all of the devices mounted in the can of the panel, and um, please refrain from discussing the legalities of that, but it's really going to work well for this application. So I chose a Square D panel that uses QOB, which is the QO bolt-on style breakers. And you can see the bus tabs have holes in them, and the circuit breakers are going to bolt on. So it's a QO breaker like you would normally get, except it's bolt-on tabs. And that makes it slightly more reliable at high loads because you get less heating at the bus. And these buses stay, but you could replace the individual runners here, these tabs, if you have a burnout. They'll also take the QO standard breakers. They'll clip on here. I don't plan to do that, but that's also a possibility. If you're in an emergency and Granger can't get you a breaker to fit this panel fast enough, you could just go to a local store and get a replacement breaker. I don't have this shop operational yet, so I don't have the CNC or any way to make patterns for the plasma cutters. So I've been cutting out these holes with a hole saw, and it's been going okay. So I have these 5 in the back here, which is 2 L630s, 240 volt twist locks, and then 2 L520s, and then 1 520 straight blade convenience outlet in the back there. And then I just installed another hole on the side here for a 1450, which I'll use for charging the car, maybe. Also, I have an inverter that's got a 50 amp input that has the same plug on it. So I tilted this one a little bit so that if I add more above it, the cords won't interfere because they'll pass out the side of each one. And in the back here, if you can see back there, you'll see the outlets in the back there. One of them is really local. It's going to be for this heater, which is just mounted on a little swing arm on this cart, which has an air machine and a paper towel holder and a shock vac and some other stuff. And I also have a breathing air pump hanging down at the bottom. So I'll power the cart, and then other cables will come off of that. And I have a 100 amp pin sleeve for the TIG welder. And I'm going to keep cutting these holes with hole saws and measuring out and laying out the screw hole pattern for them. So these are some of the saws that I've been using. This is 1 3/8. I got good Morse hole saws because I wanted the holes to be clean. This is 1 1/2. So the 1 3/8 does the round 15 and 20 amp receptacles, and then the 1 1/2 will do all of the standard twist lock receptacles, the locking kind. And then this is a 2-inch saw for the 1450 outlet, but that 2-inch is a little too small. The 1450 comes out at 2.09, which is kind of in between 2 1/16 and 2 1/8. I would prefer to have it a little tighter, so if I had a chance to buy again, I would probably buy a 2 1/16 and then clearance the hole. I had to use a double helix carbide burr on a die grinder for clearancing the 2-inch hole, because I had to take out quite a bit of material, and I had to make way for the 1450. Also, this is the pin sleeve for the welder. So it's a 100 amp 125 250, so it's got a neutral, which the welder doesn't use a neutral, but this was the plug I found. So I will send a neutral on its wire. I have a 4-conductor wire on the welder, so it's no big deal. And then this is the outlet for it. This is kind of like, if I can get this darn thing open. This is kind of like generator, lift station hardware, and applications like that. Or like in a big factory where you had a big machine. And they're also IP65, which I don't need. And here's my welder cable. This is a number 2. I previously cut the neutral off, but I'll terminate that in the plug later. And I have 50 feet on the welder here, so that'll be able to stretch over there and plug in. The idea is when this shop has to rearrange or move, I'm not constantly installing new electrical equipment and hardware. I have a big pile of SOOW and SEOOW cabling that I'm going to make all these wires with, and so I'll be terminating plugs on all those cables and for the various loads, and maybe I'll make another video when I get further along. But if you have any questions, pop them in the comments, and I'd be happy to try and answer them. Oh, this is a single phase panel, by the way, and its model number is QO30L2C. So that's a main lug, 200 amp interior, I think. This panel also comes in 400 amps. And when you buy it, you buy the can and the interior and the cover all separately, usually. And so you can specify different size cans and stuff. This is a super industrial panel, and it allows large clearances in depth. This depth allows these devices to clear any wiring coming out of the circuit breakers at a different plane. And also it has a lot of extra width, so the can has plenty of space for mounting these devices. So anyway, so that's gonna be that. Oh, I'm also gonna pull the bottom off. It's removable, and I'll cut all of the device holes in the bottom, which is where most of the stuff is gonna come out of the bottom. And I also have a selection of type SC. This is just 6 gauge because I have a small service inlet in this building, but this is type SC cable, so I'll use this in single conductor to feed the panel. And then I also have a SEOOW. I like the SE instead of the SOOW because it doesn't smell bad. So this is a number 6 by 4 conductors, and I'm going to make a 1450 extension using these ends here. So anyway, that's the project. I hope you find it interesting. Thanks. Bye-bye.